In this video, I'll give an example of a cylinder rolling down a ramp, looking at the kinetic energy. So I've started with a drawing, list of my knowns and the unknowns, things I need to find. So we're looking for final kinetic energy and how much of that final kinetic energy is rotational, how much is translational. So in my sketch, I've drawn the height of the ramp and the length of the ramp. Here, I didn't draw all of the numbers on my cylinder because it's just too small. So I haven't added those labels to the figure. So finding final kinetic energy, best way to go about this is to use conservation of energy. There are no external forces that are affecting the cylinder. So initial energy equals final energy. All right, so initial energy. Since the first question is just asking about total kinetic energy, I'm not going to split it into rotational and translational, at least to start. So initial kinetic, initial gravitational, initial elastic or spring, initial thermal, and then final. Okay, kinetic energy initial. We know it starts with V naught equals 0. It's not moving initially. So that means this one is 0. Gravitational initial. If I call this at the bottom y equals 0, then yes, it does have gravitational at the start. It starts with mg, and then here I call it h ramp. So mg h ramp is the starting gravitational. There's no spring, so that goes away. Thermal, there is no air resistance holding it up, anything like that, so we don't need to worry about thermal. Final kinetic energy, that we have. That's what we're looking for. Final gravitational, it ends at y equals 0. So there is no final gravitational. No spring, no thermal. That's not so hard. So K final is m2.0 kg, g 9.8 meters per second squared, h ramp 0.75 meters, 14.7 joules. So that's the first one. Now we need to figure out, of this 14.7 joules, how much is rotational, how much is translational. Those two things are connected. If we've got something rolling along at some omega and some v, they are related by r. Omega r equals v. That's true for anything that is rolling without slipping. Should call that v tangential. All right, so K final is K rotational final plus K translational final. So that's 1/2 I omega squared plus 1/2 mv squared. Okay, so what is I? This is, oh, I didn't write it on here. I should have written solid cylinder, because that's important. So what is I for a solid cylinder? A solid cylinder is like a solid disk, just very thick. So it's the same. So I for a solid cylinder is the same as I for a disk, which is 1/2 mr squared. So this is, now this is the rotational part, that is the translational part. So this is 1/2 times I is 1/2 mr squared omega squared plus 1/2 mv squared. So we want to remember that is K rotational final. This is K translational final. We can convert this V into an omega. So this is 1/2 times 1/2, so this is 1/4 mr squared omega squared plus 1/2 mv squared. V is r omega. So this is 1/2 mr squared omega squared. Now that's interesting because now we can see that this one is twice as big as that one. So K translational final is actually 2 times KR final. So now we can come back here actually and say K final is KR final plus KT final is 2KR final. So 2KR final. So I can put that here, 1/3 K final, and that means the other 2/3 is translational.